To make a better comparison, let's simulate both these circuits together, right? Base is grounded, emitter is grounded here. Here base is grounded. Now you have to set VBE as 0.7, right? It means you have to drag emitter voltage to minus 0.7. Here emitter is grounded. To make VBE as 0.7, you have to drag or increase the base voltage to 0.7 to have VBE 0.7. Then here you increased VCB yourself, VCE, right, is produced itself, right? Here you increase VCE, you select VBE, and VCB produces itself for the current values of both these things, right? So what is new? Basically it's nothing new. You actually want to see if you take emitter as constant and increase the base and increase the collector with reference to emitter, right? You have to plot this thing because you are taking collector voltage with reference to emitter, and here you control this, and this produce itself. Basically we want to see if you take base as common, right, and you have to change emitter and collector with reference to the base, right? So it means you want to see some parameters related to base. So that's why you plot VCB, collector with reference to the base, and emitter with reference to the base, right? So collector with reference to the base, collector current, and this curves are for every VBE. Here they wrote IE, so it's same. For every value of VBE, you have some IE, right? Same as here. For every value of VBE, we have something IB, right? So you marked each curve for specific VBE or for specific IB. Same here, you mark each curve for a specific BE or IE, right? So if we choose this also 0.7, already 0.7, so minus 0.7, right? Here BC is 0.7, so to compare we want to plot the same thing, VCB and VCB, right? So it's 0.7, right? So VCE is basically set to 0. Here VCE comes to be the 0, so that's why we choose minus 0.7 to make these two values same for better comparison, right? So if I want to plot both the curves together for this circuit or for this circuit, we got the same things, right? I mean to say, for this circuit, if you vary VCE yourself, VBE set yourself, right? So you get some values of VCB, right? Now you can have two plots, VCE IC or VCB IC. You got the same plots. Here also you vary VCB yourself, VBE set yourself, this comes itself, but still you can have two plots, collector current versus VCE, right? Collector current versus VCB, the same things, right? But why only this curve is shown for this thing and why only this curve is shown for this thing is because for common emitter as referenced, it means you want to see each quantity with reference to the emitter, right? Same is here. Base is common, so you want to see the quantities, for example, same collector voltage, but now you have to see with reference to the base. So that's why these curves are called common base characteristics curves, right? So if you increase your VCE from 0 to say VCC, and here because you are controlling VCB, so increase minus VCB minus 0.7 to say some positive values, you can see these things are same. This is increasing from minus 0.7 to some values, and this is 0 to some values, right? So you can see you are now at the edge of the active and saturation regions, right? And we stop here just to show you the saturation region, right? Now if we go further, so you can see even you are controlling this thing, this is changing itself. Even you are controlling this thing, this is changing itself, right? So this is the characteristics curve. So in your book you have the same plots, but you have this circuit, so please don't be confused. You can see VCB is same, so instead of showing VBE by making base as common, they showed current source, so the same, right? Here for a voltage source you must be having IE, so for a current source you must be having a VBE, so nothing different, right? So this is all about common base characteristics. Now come to the topic, common base amplifier.